Well, hello there everyone. I'm sorry you can't see my face, but the reason for that is due to the limitations of my recording device and the size of my whiteboard here. There's unfortunately not enough room for me. So if you're dying to see my face, you can check out one of my other videos, or you can just savor the mystery. Either way is fine. So I was inspired to start making these videos as a result of my current job. I currently I tutor math. I've been teaching and tutoring math and various other subjects for about 4 years. And in the course of my work, I of course meet many students who dislike math and can't do it. And as I've thought more about this, I realized that the reason most people don't like math and can't do it is because they were taught badly. And so to remedy that situation, I decided to do what I can to help those who want to get better at it. So it doesn't matter if you're old or young, student, maybe a homeschooling parent, a teacher. If you're anyone who wants to get better at math, this video I think will be helpful for you. And if you've struggled with math and you've been frustrated by it, and it's made you unhappy, that you can just put all that behind you, because we're going to start fresh from the very beginning, and it'll be hopefully nice and easy. So to begin, talk a little bit about numbers. Well, obviously we'll be talking a lot about numbers, but the first thing we need to think about is the numbers we use today. Of course, we're familiar with 1, 2, these numbers. And of course, at the very beginning, we also have 0. So these symbols that we use to mean numbers came about, the ones we use came about 500 years ago in Europe. And these ones in turn were borrowed from a system used by the Arabs, and that system was in turn borrowed from mathematicians in India. So it's a long, interesting history. Don't worry, I'm not going to get too much into it. But I will touch on the fact that before we used these symbols in Europe, for a long time they used what were called Roman numerals. So you might see these on old clocks, or at the ends of movies. The copyright date will be in Roman numerals, or on buildings. The cornerstone will usually have the date the building was built in Roman numerals. So you have I, V, X, L, C, and M. So I is 1, V is 5, X is 10, L is 50, C is 100, and M is 1,000. So for smaller numbers, it's okay. So for example, 2 in Roman numerals is like that, or rather, don't worry, I'm not going to spend too much time on this. And if it was, say, 15 in Roman numerals, that would just be X and V. But things start getting more complicated as the numbers get bigger. So for example, if I wanted to write the number, or rather the date 1979 in Roman numerals, it would be MCM, let's see, and then so the MCM is the 1900 part, and then for 79 that would be LXX, and then IX. So you can see that the symbols we use to write numbers, it's a lot more compact than Roman numerals, and this is the big reason why the switch was made. And if you try to do any math in Roman numerals, it's ridiculously complicated. So fortunately we have these nice convenient symbols to use. If you thought math was hard with regular numbers, you should try it with Roman numerals. Okay, so that's a little bit about the history of the numbers we use and how they came about. So for most people, the bridge to math is language. So first we learn how to speak, and then we learn about these things called numbers, and we learn the names of the numbers. And when people are learning to count, they count on their fingers, so they count 1 to 10. Then we learn the words first, obviously, before we learn the symbols. And then, as in kindergarten, you get taught about the bigger numbers. You learn to count from 1 to 100, and you also learn about 0. And then after 100, as you get, maybe second or third grade, you learn about still larger numbers. So you learn about 200 through 1,000. And then you learn about even bigger numbers, like 10,000 and so on. And there are still larger numbers than that, like million and billion and trillion, and we'll talk about those in a few later lessons. But those are the numbers we'll be working with so far. We'll just pay more attention to the smaller numbers. The most common application for, after we learn how to count, the most common problem we encounter is how do we put two amounts we counted together. So for example, if you earn $5 or let's do some more realistic amounts. You walk 3 miles one day, and 5 miles the next day. How far did you walk in total then? So, to answer this, we need to do addition. I realize at this point that there are probably plenty of people watching who are familiar with addition and basic math and so on, and if it seems like I'm spending too much time on an obvious point, it's because I want to be thorough and make sure everything is clear and easy to follow. So that's why I do that. So if we were to do this by the intuitive and easy way of using our fingers. Okay, so we walked 3 miles the first day, and then we walked another 5 miles the next day. So we go 3, and then 1, 2, 3, 4, 5. Okay, so 8. So 3 plus 5 is 8. Whoopee. So the finger method's easy enough if you can count for smaller amounts, but for larger numbers you're going to run out of fingers, so we need a new method. So suppose instead of 3 and 5 making 8, what if we had a bigger number? What if we had like 12 and 9? How would we figure that one out? Well, the first thing we can do is we rearrange it like this. And when we do this, we can see that the first thing we can do, we can add these two single-digit numbers together first, and then we can worry about this part later. So the traditional method of teaching addition involves, doing lots of exercises where you memorize all the combinations of single-digit numbers. But if you wanted to memorize all the combinations of single-digit numbers like 2 plus 2 and 1 plus 1 and 1 plus 3 and all down the line, you end up having to memorize about exactly 100 sums. So, what a nightmare that is. So instead of trying to memorize all that, I think I can use a somewhat simpler method that doesn't rely on so much memorization. So going back to our example here, so the first thing we can do is we can take this 2 and add it to the 9. So since we can't count that, well, we try to count it on our fingers, but we run out. So instead what we're going to do is we're going to make tally marks. So first I'll make the tally marks for the 2. So 1, 2. Alright, now I need 9 more. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here's 5, and there's 5, and there's 1. So 5 and 5 is 10. You can do that on your fingers, then one more makes it 11. So you write the 1 from that 11 down here, and then we take the other 1. This is called carrying the 1. And then we have 1 plus 1 is 2. As you can do that on your fingers. So there we have it. So I realize I say ah and so a lot. Try not to do that, but it's a habit. By breaking this down into single digits, we can do it pretty easily. And this is the key to learning math, is breaking it down into simpler steps. And it doesn't matter if it's arithmetic, algebra, calculus, whatever. And at this point, I think it might be a good time to touch on the use of calculators. So a common question that students have had for a long time, and that is a question that even I asked when I was in school, is why bother learning how to do math by hand when we have calculators? And the reason we must learn to do math by hand, or you should learn how to do math by hand before using a calculator, is a calculator can't tell if you've made a mistake. So if you punch the wrong buttons and then hit equals and you see your result, unless you have an idea of what the answer should look like, you won't know if you've hit the wrong buttons. So for example, if you think you type into a calculator, I don't know, 11 plus 43, you think you type this in, so I'll put, this is what you thought you put in, and the calculator tells you this is 670. If you haven't practiced enough math to know that 11 plus 43 has to be a lot less than 670, you're not going to notice your mistake. So this is why it's important to learn how to do math by hand before you use a calculator. And the other lesser issue is that to use a calculator properly, you have to know what buttons to push and when. And if you can't do that, you're not going to get the right answer either. So bottom line, you should never do anything on a calculator until you know how to do it by hand. So moving along, we'll come to slightly more elaborate addition problems. So we know how to do single-digit numbers being added together. That's easy enough. And then we talked a little bit about how you add together numbers that will come up to something bigger than 10. So we had 12 and 9. We found out that's equal to 21. And we can use a variation of this process to add numbers as large as we want. So if we had 24 being added to 57, using our tally method, so first we'd have 1, 2, 3, 4. Then we need 7 more. So 1, 2, 3, 4, 5, 6, 7. Okay, so 5 and 5 and 1 is going to be 11. So we put a 1 down here. The other 1 we carry. So 1 and 2 is 3. 3 and 5, you can do that on your fingers, it's 8. So that's easy enough. And to do one more example like that, if we had 67 and 46. So first, I mean, it doesn't matter which way you do it, but we'll talk more about that later. There's a reason for that. Starting with the 7. 1, 2, 3, 4, 5, 6, 7. And with the 6. 1, 2, 3, 4, 5, 6. So we got 5, 5, and 3. So 5 and 5 is 10. And 3 more make it 13. Put the 3 down here. The 1, put up here. So it would be 1 and 6 is 7. And then 7 and 11 is going to be, actually you could say the 6 and 4 is 10. And then 1 more make it 11. So we write the 11 as it is. And then I should do, so far in all these examples I've been carrying the 1. You can carry other numbers 2 as well, but we won't get into that until we talk about multiplication. And actually I have a different method for that. So anyway, let's see, we could do a couple more slightly elaborate, more elaborate examples. We have 128 and 357. So for the 8, you have 1, 2, 3, 4, 5, 6, 7, 8. For the 7, 1, 2, 3, 4, 5, 6, 7. 5, 5, and 5 is 15. 5, carry the 1. 1 and 2 is 3, 3 and 5 is 8. And 1 and 3 is 4. And the reason why I'm doing a couple example runs, this is a very important point. You can't get good at math without practice. You have to do a fair number of practice problems, and the more you do, the better you get at it. And that's pretty much all there is to it. Practice makes perfect. I have numbers like this. Should put the plus sign down a little lower. It's an aesthetics thing. 1, 2, 3, 4, 5. Whoops. 5, 6, 7, 8, 9. And then the 8. 1, 2, 3, 4, 5, 6, 7, 8. So 5, 5, and 5 is 15. And 2 more makes it 17. Okay, 1 and 7 is 8. So to do 8 and 8, we can do our tally method again. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 5 and 5 is 10. 10 and 5 is 15. 15 and 1 is 16. Put our 6, carry the 1 again. 1 and 6 is 7, and then now we have 7 and 9. So first to the 7. 1, 2, 3, 4, 5, 6, 7. And then the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 16. There you go. So I was able to do these fairly complicated addition problems without needing to memorize too much. All you need, if you use the tally marks, you can, and you're careful, you can get to the right answer every time, and you don't need to memorize too much. As you do many problems, you will eventually memorize most common sums, but you don't have to. And so that's about all I wanted to do. I suppose I'll end the lesson there, and then for the next video I'll bring up the topic of subtraction and my method for doing that, which I think is a little bit easier to use. And so that will be the topic for the next video. So thanks for watching, and I hope this video was useful to you.